Okay, so if I want to find the area of the square, if I'm building a table, I would multiply the size. So 3 times 3 is 9. This is pretty much review. And radical 5 times radical 5 is just 5. So the area of this tabletop would be 45 feet squared. Okay, so now, if I wanted to add a couple feet to it, I would use the same concept. I already know how much 3 root 5 times 3 root 5 is. How much is that? 45. We just found that in the last example, right? But what am I going to do with this? Add on the end. So how would I multiply that? But you would add it to the top, but look at, you still have to account for this times this gives me this area. Correct? So how would I find that? Yes, Connor. How do we figure this one out? So how do we figure this one out? So how much is 2 times radical 3 root 5? So the square foot area would be 45 plus 6 root 5. See that? Okay. So go ahead and write these down, please. Okay, so let's go ahead and set these up. I have a root 3 that I'm going to multiply by what? I'm going to multiply it by 2 root 5, and I'm going to multiply it by negative root 3. Distribute that root 3 to everything inside the parentheses. Just like you would do if you had another problem where you had a number on the outside and parentheses and 2 numbers on the inside, right? We distribute. So what is root 3 times 2 root 5? Okay, I don't see any squares in here to worry about, right? So I just need to multiply it. So 2 root 15. And what's root 3 times root 3? Negative 3. Good job, guys. You see why? Root 3 times root 3, that's just like rationalizing the denominator, right? If it has the same root, and we multiply it by itself, it becomes root 3 squared, or just 3. So my answer to this one is 2 root 15 minus 3. What about this one? What do I put on the outside of this box? 2 root 2 times root 10 plus 4 root 2. I see a square in here, so I'm going to be careful about that. I have 2 times, I'm going to find my squares as I'm multiplying. Root 2 times root 10 makes 2 squared times what? 5. I immediately factor it. I see a 2 and a 5 in there. I see a 2 in here, so I need to make sure I take into consideration that there's a square in there. We'll deal with it later. Plus, I also have a square here, correct? Let's deal with the outside first. What's 4 times 2? 8. And a root 2 times a root 2 makes 2. So I'm going to have to multiply by 2. Almost. So I have to kick out a 2. What happens when I kick that 2 out? It multiplies by this other 2, which makes 4 root 5. And 8, if this confuses you guys, just write it out. This is the same thing, right? 8 times 2 is 16. So far, so good? I forgot to draw my rainbow. I was distributing 2 root 2 to 10 and 2 root 2 to 4 rad 2. Can I continue? All right. Go ahead. So let's look at these. Now we've got a little bit different of a situation, right? We already figured out what 3 root 5 times 3 root 5. You don't need to write this down. Yes, Connor? Almost. It's a little bit of a difference. I'm going to move it down here because I think it's easier to understand. Why do you think it's so big? Somebody tell me. That too. Isn't this 3 root 5 times 3 root 5? And we already know that that's 45. That's from the very first problem we did, right? We also did this problem. Does anybody remember what 3 root 5 times 2 is? What is it? I gotta make it pretty. So this was 6 root 5. But now we have this guy right here. Where's this guy go? Bottom. Now it looks like, what does it look like? What have we done in the past like this? Multiplying binomials. So what's 2 times 3 root 5? 6 root 5. And what's 2 times 2? Finally, we just have, what do we do when we're multiplying binomials like this? What's our last step? Combine like terms. Good. I see a 45 and a 4. Those look like terms. What's 45 plus 4? And I see a 6 root 5 and another 6 root 5. I don't want to write that all out. So if I have 6 root 5s and 6 more root 5s, how many root 5s do I have total?
12.
This is why I showed you the expanded form. When you write out 6 and you write out 6 more, how many do you have total? 12 root 5 would be my answer. Okay? Let's do that together. Let's set these up. I'll give you a second to write these down. Okay, let's set these two up. How can I set up 8 plus root 3 squared? What does this mean? It means there's 2 of them. So I could put one of them here and one of them here using the area model. What's 8 times 8? And 8 times root 3? And here? And what's root 3 times root 3? 3. Yes. Okay, let's combine like terms. What's 64 and 3? 67 plus, what's 8 root 3 plus 8 root 3? 16 root 3. Better. Okay, finish this one up on your own. Okay, I don't see any squares, so no harm in multiplying it. So 6 times 4 is 24, and root 7 times root 10 is root 70. Okay, what about this one? See any squares? When I multiply 7 and 6, are we going to get any squares? No, so let's just multiply. 6 times negative 5 is negative 30 root 42. Good. I do, however, see a square here. So I'm going to multiply 4 and 3, which is 12. And then I'm going to consider the fact that I've got a 2 in here, and I've got a 2 in here. So So I have a 2 squared times 5. And the same thing with this one over here. Negative 5 times 3 is negative 15. I know I have a 2 in here and a 2 in here, which is going to make 2 squared times 3. All right. 24 root 70. Is there any other root 70s in here? We need an equal sign here. There's no other root 70s. So that guy's going to stand alone. 24 root 70. What about root 42s? Any other root 42s? Nope. Can't do anything with that. So it's negative 30 root 42. What about this one? What can I do with this? Kick out that 2. When I kick out the 2, where does it go? Outside. I have a 12 out there. So what am I going to multiply by? So I get positive 24 root 5. And with this one, kick out that 2, and it becomes negative 30 root 3. All right, let's move on to rationalizing using conjugate. I want to show you guys something really quick. So pencils down. Give me a sec. Does anybody remember what we call this? What is it? It's 2 binomial, right? It's got another name. It looks like this. Remember that what that's called? Difference would be you needed a subtraction sign. This is a perfect square trinomial. So if I were to work this out, it would be x squared plus 4x plus 4. Okay? Using the same method, right? The box method, you'd multiply, correct? What about this one? What's that? That's a special product as well. What's that one? The difference of 2 squares. How would I figure this out? You guys should know this without even having to multiply them. The difference of 2 squares is really just the first term squared and the last term squared, and what goes in between them? A negative sign, the difference of 2 squares. Remember this? We're going to use this same approach. Okay, let's do another one. So if I had y plus 2 times y minus 2, what would be the difference of 2 squares? Y squared minus 4. A plus b times a minus b, what would that one be? A squared minus b squared. And why does that work out? Does anybody remember? There's a specific reason why.
Because
these signs right here, since they're different signs, they cancel each other out. This becomes a negative 2x, this is a positive 2x, negative 2x and positive 2x cancel each other out, right? Okay, that being said, we're going to use that to rationalize using a conjugate. I can't just multiply this now by this. Why can't I do this? Because there's a negative sign here. So I have to treat this problem as just like I would a binomial. So does anybody have an idea what I could multiply by? Giving you the clue that I just did on the last page. 5 what? Look at this one. I'm trying to get rid of a rad 2, right? I want to do something that's going to cancel the rad 2 out. What did I do on this page to cancel these out? How do I get rid of, this was a negative 2x and a positive 2x, right? put a negative on one and a positive on the other. So how would I do that with this? And I'm going to show you how it works. But for those smarty pants out there, can anybody tell me what this denominator is going to look like? What was this one? What if I had y plus 4 times y minus 4? What's that look like? So what's this one going to look like? A rad 2 times a rad 2 would be, a rad 2 times a rad 2 is a 2, so it will be 25 minus, which would be 23. All right, let me show you how it works. 5 times, it's 5 minus rad 2, and 5 plus rad 2. 5 times 5 is, and 5 times rad 2, 5 rad 2, and negative 2 times 5, negative 5 rad 2, and rad 2 times rad 2 just makes makes negative 2. These cancel each other out. So I'm just left with 25 minus 2, the difference of two squares. That's this squared, right? 5 squared minus rad 2 squared. That's what it is, right? It's the difference of two squares. Doesn't it look like the difference of two squares? Okay, so if that's my denominator, let's take care of the numerator. Change my color. I still have to multiply 3 times everything in here. When I multiply times everything in here, don't I just distribute? Patrick? Enough. 3 times 5 is, and 3 times rad 2. So my answer is 15 plus 3 rad 2 over 23. This is as hard as it's going to get on the quiz or the test. Let's do another one. Write these two down. Okay, so in order to rationalize the denominator, don't I have to make this the difference of two squares? You see it now? Right? So when I do this, I'm actually just squaring the first term, which is root 7 times root 7, which is 7, and squaring the last term, which is root 3 times root 3 is 3. That's what I was doing in my head. Let's do it over here. Root 7 plus 3, root 7 minus 3. Root 7 times root 7 is 7. Root 7 times negative 3 is negative 3 root 7. This is going to be positive root 3, 7. Those cancel each other out. And I'm left with a negative 9. Oops, this was supposed to be root 3. You guys are letting me make mistakes here. So this is going to be, whoops, negative root 21 and positive root 21. Sorry about that. And root 3 times root 3 is negative 3. These cancel out. These cancel out, and I get 7 minus 3 equals 4. Turn around, please. So the last thing I need to do is distribute, correct? 5 times root 7 is 5 root 7. And 5 times negative root 3 is negative 5 root 3. Yes, Anthony, thank you. All right, last one. Do you want to do this one yourself?
No.
Okay. What am I going to multiply by?
8.
3 minus root 3. Not 3 minus 9 minus 3, right? Over 3 minus root 3. Let's figure out what that is. Some of you have already figured it out. Three times 3 is 9. This is going to be negative 3 root 3, and this is going to be positive 3 root 3. They cancel each other out. And root 3 times negative root 3 is negative 3. 9 minus 3 is 6. Now we just have to find the numerator. And I'm going to distribute. 8 times 3 is 24. And 8 times negative root 3 is negative 8 root 3. And we're done.